Hello, everyone. Today, I would like to present to you this poster titled Phenomenological Studies in the Two-Fixed Doublet Model and Standard Model using MadGraph5 by Sergio Sicairos Paez and my thesis director, José Hernandez Pinto. For this presentation, we will start with a motivation, followed by a brief explanation of the two-Higgs doublet model. Then after that, we'll talk about the phenomenological studies in this model, and then we'll present to you the results of the simulations we made. Finally, we'll show our conclusions and the references. So far, the standard model has been extremely successful when it comes to describe the fundamental interactions among particles. Nonetheless, several unsolved questions have arisen from experimental results in the standard model. For example, the mass of the neutrinos, the asymmetry that exists in the universe between matter and antimatter, the origin of dark mass, among others. This is why there are several groups dedicated to build models that extend the standard model's paradigm, such as the model we are exploring here, the two-Higgs doublet model. This is one of the simplest models beyond the standard model. It contains two Higgs doublets instead of just one. When we add this second doublet, we get richer phenomenology, as it contains new scalar states, such as two charged Higgs bosons, a CP odd pseudoscalar A, and two bosons that act just like the regular Higgs, just one heavier than the other. The lighter Higgs is the one we already know from the standard model with the mass of 125 gigaelectron volts. Both of these Higgs are responsible for the mass of the particles of the standard model. The potential of the two Higgs doublet model of type 2, which is the one we are exploring here, in this model, the flavor changing neutral currents are ignored. Is given by this potential here, where the vacuum expectation value is as these expressions. Also, in this model, we have these 7 independent parameters, which are the ones which define the model. In this work, particularly, we study the kinematical distribution of variables in the process of two protons colliding and producing two jets and one Higgs, where we center our attention on the experimental reconstruction of these dijets. For the PDF, we use NNPDF 3.0, which is the LHPDF of MadGraph by default. Furthermore, we implement the standard kinematical cuts for the LHC, which are the transverse momentum of the jets, the rapidity of the jets, and the separation between these two jets, which are these 3 parameters. Besides, we explore the sensitivity of these cuts for the future circular collider. Here I show you the results of the simulations. Here the parameters that we used for the masses of the Higgs were 120 gigaelectron volts for the lighter Higgs, the 130 for the heavy Higgs, and for the pseudoscalar A, a mass of 150. In this first plot, we show the angular distribution, where, as we can see, there is a peak for the standard model at pi and another peak at 0. And for the two Higgs doublet model, it has it is more uniformly distributed. Now, for the transverse momentum, we can see that in this case, the scale is logarithmic, and we can see this peak at 0 for the two Higgs doublet model, which in a regular scale is much bigger. Also, in both models, it decays, but the two Higgs doublet model decays faster. To the right, we have the standard model, showing a peak at around minus 2.5 and 2.5. And for the 2 Higgs doublet model, there is a single peak at 0. Now, for the simulation in the FCC energies, we have the angular distribution between both models, and we can see the standard model shows a peak at 0 and another peak at pi. And for the 2 Higgs doublet model, there is a peak at 0 and is a little more well distributed. Now for the transverse momentum, we can see that it also shows a peak for the 2 Higgs doublet model at 0, and they both decay, but the 2 Higgs doublet model decays faster. Finally, for the FCC energies 2, we have 2 peaks for the standard model, one around minus 4 and the other one around 4. And for the 2 Higgs doublet model, we have a peak around 0. Now, experimental evidence supports that there are some discrepancies in the standard model that are not well understood yet. Hence, in order to solve them, new models that extend its limits seems to be a good approach. One of the best options we currently have to extend the standard model is the 2 Higgs doublet model, because it naturally brings new phenomenology that might fit the subtle results that standard model fails to explain. In this work, we study the potential of the 2 Higgs doublet model in the LHC and the FCC studies. The phenomenological contributions of the 2 Higgs doublet model make a substantial change to some observables, which make it important enough to be considered for future analysis. A detailed analysis of the phenomenology is under examination for more experimental variables. And I want to show you here some of the references used for this work, and thank you for your time.